Let us take a look at question number 2. The question says that a loaded railway wagon has a mass of 15 tons and moves along a level track at 20 km per hour. It overtakes and collides with an empty wagon of mass 5 tons, which is moving along the same track at 12 km per hour. If each wagon is fitted with 2 buffer springs of stiffness 1000 kilonewton per meter, we are to find the maximum deflection of each spring during impact and the speeds of the wagon immediately after impact ends. If the coefficient of restitution for the buffer spring is 0.5, how would the final speed be affected and what amount of energy will be dissipated during impact? Now let us look at the solution to this problem. Now let us itemize our given. We are given the mass of the loaded wagon, let it be M1, which is 15 ton, which is equal to 15,000 kilogram. And we're given the initial speed of the loaded wagon. Let's call this one U1, which is 20 kilometer per hour, which is equal to 20 multiply 1000 divides 3600, and this gives 5.55 meter per second. Then we are given the mass of the empty wagon as 5 tons. Let's call that one M2, which is equal to 5 tons, which is equal to 5,000 kilograms. Then we're also given the initial speed of the empty wagon. Let's call this one U2, which is given as 12 kilometer per hour, which is equal to 12 multiply 1000 divide 3600, and this gives 3.33 meter per second. And we are also given the stiffness of the spring. If you say S as the stiffness of the spring, and we're given to be equal to 1000 kilonewton per meter, and this gives 1 times 10 raised to the power 6 Newton per meter. Then we are also given the coefficient of restitution E to be equal to 0.5. Now let us analyze this. The moment the impact takes place, both wagons will move with a common velocity for a short while before they separate. So let V be the common velocity of the two wagons at the impact. Because what happens is when two bodies collide, even though if they are going to separate, at the moment of impact, they will move up with a common velocity for a short while before they separate. Let us write momentum equation here. Momentum equation. Now momentum before impact is M1 U1 plus M2 U2. Then momentum after impact, since they move off with a common velocity for a short while, is going to be M1 plus M2 multiplied by V. Then from here, V is equal to M1 U1 plus m2 u2 over m1 plus m2. When we substitute the value, we have 15,000 multiply 5.55 plus 5,000 multiply 3.33 over 15,000 plus 5,000. So when you evaluate this, you have the velocity to be equal to 5 meters per second. Now, for maximum deflection, let x be the maximum deflection of each buffer spring. Now, we already know that S is the stiffness of the spring. Now, strain energy stored in one spring, strain energy stored in one spring is equal to a half Sx squared. When we substitute, that energy is equal to a half multiplied by our S is 1 times 10 raised to the power 6, then x squared. And this gives 500 times 10 raised to the power 3 x squared, measured in Newton meter. Then, what next is that since the 4 buffer spring, because each wagon has 2 buffer springs, so we have a total of 4 buffer springs. So since these 4 buffer springs are strained, therefore the total energy, strain energy stored in the spring is going to be, so total energy stored in the spring is going to be the energy of one buffer multiplied by 4. This will be 4 multiplied 500 times 10 raised to the power 3 x squared, and this gives 2 times 10 raised to the power 6 x squared, still in Newton meter. Now, difference in kinetic energy before and during impact is given as XL is given as m1 m2 over 2 into m1 plus m2, then multiply u1 minus u2 square. Then when we substitute the value, we have 15,000 multiply 5,000 over 2 multiply 15,000 plus 5,000. Then multiply our u1 is 5.55 minus u2, which is 3.33 square. When we evaluate this, we are going to have 9240 Newton meter. And the difference between this kinetic energy, as I've said, as I always say, energy is never lost. This difference in kinetic energy before and kinetic energy during impact is absorbed by the buffer springs. When we neglect all losses, it must be equal to the strain energy stored in the 4 springs. For this, we equate this energy E, ET is equal to EL, and this implies that 2 times 10 raised to the power 6 x squared must be equal to 9240. Then from here we have x squared is equal to 9240 divides 2 times 10 raised to the power 6. From here, x is equal to the square root of 9240 over 2 times 10 raised to power 6, and this gives 0.068 meter, which is 68 millimeter. Now let us take a look at speed of the wagon immediately after impact ends. What happened here is that immediately after impact ends, both wagons will now move separate with different speed. Now if you take V1 as the final speed of wagon 1 after impact, and then V2 as the final speed of wagon 2 after impact, then we know that V1 is given by this expression 2V minus U1. So which is equal to 2 multiplied by 5 minus 5.55, and this gives 4.45 meter per second. Then also V2 is going to be 2V minus U2, which is equal to 2 multiply 5 minus 3.33, and this gives 6.67 meter per second. So since E, the coefficient of restitution, is given as 0.5, we must take it into account. That is, E is equal to 0.5, then V1 is going to be equal to 1 plus E multiplied by V minus EU1. And this will give us 1 plus 0.5 multiply 5 minus 0.5 times 5.55, and this gives 4.725 meter per second. Also, V2 is going to be 1 plus E into V minus EU2. When we substitute, we have 1 plus 0.5 multiply 5 minus 0.5 multiply 3.33, and this gives 5.635 meter per second. Now, the next thing here is we need to consider the amount of energy dissipated during impact. And we know that the energy dissipated during impact is the difference in that kinetic energy given. Then we are going to account for the coefficient of restitution here. So the amount of energy dissipated is given as EL, which is equal to M1 M2 over 2 multiply M1 plus M2 multiply U1 minus U2 or square into 1 minus E square. And then from here we have EL. The whole of this one we have calculated it to be 9240, then multiply by 1 minus 0.5 square. We evaluate this one to give 9240 multiply 0.75, and this gives 6930 Newton meter. Thank you very much. Be expecting question 3.